Today, I have a really short talk about the smart aggregation near the natural language processing tasks, actually at the text aggregation area. They may also discuss several methods about probably computer vision in question answering session, but the main thing what we want to discuss is about how to aggregate data, the textual data obtained from crowdsourcing. So the first thing what we want to note in this moment, that's actually the most crowdsourcing tasks rely on the overlap. Because then we speak about gathering data from humans, the humans may make mistake, and that's normal. That's totally classical things that's happen in our life. So then you use crowdsourcing. Most often you ask several people, several annotators to provide answer for some task, for example, classify some text or route something or something else, to know several answers and choose the best or aggregate them or something like that. So the classical overlap scheme allow us to cherry pick the most interesting answer, the most correct answer for our tasks for any kind of generally tasks. Actually, they may use this approach to for diversing our opinion base, probably in some questionnaire area, or probably just to negotiate the risk of some mistakes, some incorrectness from human. Probably it's something like human bias, or just the random mistake, or just the systematic error. But then they use several people's, they may rely that the correct answer will be presented. So then speak about the several answers. The first thing what we want to actually do with them is something like cherry pick the most correct, or aggregate them, or provide generally just one most correct answer. Because in classical machine learning tasks, classical machine learning algorithms and data sets, they also speak about just one item and one correct answer for them. But generally, then we speak about tasks with one item and several answers for them. It's something like the noisy data, because probably our answer may be different from one, and the most understandable approach to work with this data, just aggregate them. For example, using the majority vote aggregation, just they pick the most common item to say, okay, it's probably most likelihood, most relevant answer for our task, because a lot of people thinks that's a correct answer. Okay, let's believe for them. But in this approach, we don't use any expectation about the skill, about the quality of the workers, and probably different performers have different ability to improve, to answer on the data. Probably they have, it's possible to say that they have some probability to answer correctly. For example, in such area, for example, about, it's easy to speak, for example, computer vision tasks, for example, that some people may see something and another one probably don't look at such kind of things. Probably in text area, someone may understand this. Probably this phrase is toxic about hate speech detection, or probably it's something neutral or something else. And in different area, in different tasks, they may have different ability to provide correct answer for one task. So classically, they may use something like golden set values or ground truth items to estimate their probability for provide answer. Using this approach, like the point-wise estimation or the skill or probability of correct answer, they may also use this value like the estimation about the weight in aggregate or measure. Using this approach, they may also know that, for example, if the first user in our scheme oftenly provide incorrect answer because the mistakes is most popular behavior of this person. In this case, the answer cat, for example, in terms of classification, the images of these items doesn't see the correct because it's a probably mistake. So in this approach, they may aggregate the answers, the probability of correct answers, the skills, like the dates of these answers, and note that new correct answer is now one from the previous. So in this approach, they rely on several tasks, then they know real answer for them and use this estimation on known tasks, like the point-wise value of the probability to rate our examples, our answers. But generally, in this approach, about measuring the ability, and when we speak about ability, often we speak about the skill, because the skill is something like ability to perform with nice quality. So, but they use the golden sets, then they use the ground truth or honeypots. This is the similar names for one things in literature, in papers. They use just the something like 10% of tasks or something like that, because the real tasks still with unknown answer. So how we may think in this case, how we may improve? But let's firstly understand, let's firstly note that the previous one method is a real classical baseline for every task. So for every generally classification tasks with known answers, because it's more intuitive, more efficient, because it's easy to implement, it's easy to calculate, and so on. And actually is so accurate generally. It's a real cool and strong baseline for a lot of tasks. But let's think how we may probably use new information from new tasks, then they don't know any kind of correct answer. But let's think probably that's if we choose the most common answer, probably weighted answer or something like that, they may use this estimation of correct answer, something like in the golden set. But probably this answer is not correct and they need to know about them. So in this kind of the meaning, in this idea, they speak about the whole data sets, like the known values, like about observed values for us, and the note that's the skill or probability of correct answer is something like a latent variable of our model about our performers. And generally, we want to optimize the whole model and to know the skill and to know the correct answer of our tasks. So these statements sound like there's something like expectation maximization model. And in terms of crowdsourcing, this approach well known like the David-Skin algorithms. It perfectly works for categorical data, and it was involved something like 40 years ago in some medicine tasks to measure the correctness of some medical tests and so on. But it's well known in crowdsourcing area too, because it's generally the cool approach about the possibility of their work is to provide correct answer. So they look at this scheme and they use the estimation of correct answer of performance skills, like the known, like the point-wise value on golden set, on honeypots, like the first estimation. They may recalc our correct labels and the probability using the expectation maximization approach to maximize our likelihood of this data generally. So then they recall to them, we may understand that probably some skills may be changed, and they are also obtain the correct answers more with like the answer of what maximize our likelihood of this data, and generally they obtain two cool things. But then we speak about textual data. There's no any categorical things to calculate them, because the most interesting thing for us, because the number of possible words actually infinite, or generally it's continuable. And any kind of majority vote and David schemes cannot work in this area, because there's infinite space of our possible answers. But we are also may want to use overlap, because probably then we speak about, for example, transcription tasks, or probably it's maybe translation or image capture or something like that, that just one person may provide a mistake, may provide an incorrect data, and it's not the question for these people, it's a normal situation generally. But we want to reconstruct our algorithms to use this in this statement, in this situation. And for example, if they have several answers, for example, for transcription tasks, something like I love Beatles, I love Beatless, I love Beatless. It's difficult to pronounce these words with mistakes, but let's imagine. And several answers, just the, for example, fraud is just QWERTY. You may choose this QWERTY most common word, the most common sentences, the sequence of the letters, and choose this answer like the most possible, most probable, and the most correct. But as you may know, it's generally not true, because the three other answers actually they're similar, and they need to cherry pick just one of them. So let's look at the first estimation of this task. Actually, something like the first algorithm to aggregate textual data. Firstly, its name is rover. Generally, the rover is something like dynamical programming algorithm. As you may know, the Levenshtein distance is a measure of the several sequence about the editors measure how much, what amount correctness corrects to these sentences or this sequence or these words they need to provide to make from one sentences another one. So if they use this algorithm and may choose at every steps something like majority vote again, for example, they need to align our sequences, and in every step they choose the most possible, most common use value. So in this approach, they construct probably new one answer, but it's not presented in our first set of answer, but we may construct most possible value, because every token, every symbol on this answer sounds good, because it's most common value in this case. And of course, we may change the weight, for example, of epsilon token, of empathy token, and they may change the align algorithms or the sequence. But generally, it's something like majority vote on the sequences. Then they choose the most common item in our sequence at every step. But it sounds like something simple. They speak about generally about text processing tasks. There's a lot of modern natural language processing approach, and probably they may use them to do it better. So the first classical scheme for textual aggregation rely on the embeddings or our answers. And in this case, the two most popular algorithms for data for textual aggregation is RESA and HRESA. Probably I provided not correct, but actually I most oftenly read this words and not pronounce it. So the classical scheme, and it's really most cool scheme because it may be transferred from the text to another one items, for example, to the images or to probably audios or for something else, or for example, web page and so on. Then they try to transform our objects, our text to vectoral space using probably something like neural network, and speak honestly, something like BERT works perfect in this case because actually the classical transformers models works perfect for textual transformation. So they may use our vectors like their point in our some space and calculate their something like majority vote, but not actually just majority vote, something like weighted majority vote or something like centroid, or choose another one point that's may use like this center or these items. So after that, they may use the most closed vector to our center, like the most possible value to our answer, and choose from our data set, from our answers, most similar to correct answer to use them. For example, in this case, it's actually a synthetic case, of course. It's maybe interpreted like the sentences, some texts, most close to the good text, because if you speak, for example, in some natural language, people don't speak about goods, then they may speak, okay, it's just a text. And in this case, the classical approach will be classical about the mini, may choose the, that's a real good text because it's answer most similar to in our one to the just text, and note that bad text is something like critical phrase that's a real far from our answer. So, but previous method works with this data just like they're choosing their presented value. But if they speak about construction, because probably there's no correct answer in continuous space, continuous dimension of the text was presented, they may probably provide a one. Because let's think how we may aggregate several sentences if there's probably see them like the result of crowdsourcing and try to aggregate using our own brain. So they probably works like, okay, they listen to the audio and they look at the answers. They know generally the idea of the language, and we try to aggregate them using our estimation of language model, general language model, or using the whole corpus of your language. So this task sounds like the summarization of several abstract, several sentences of information. And in this case, we may use something like transformers model, and even speak about 5 models from and the most common model for text aggregation, and use the several sentences like the one huge text. It's not be actually huge, but it's something like abstract, what we want to summarize to just one sentences. Join them using, for example, sharp or space or pipe or anything. And ask our model, our transformer, summarize this information to provide the most possible value, because in this case, our transformer use knowledge about huge corpus of the language, for example, Wikipedia articles, something like that, to know the language construction and aggregate our data, like the summarization of the meaning of these sentences. And in this case, they may understand that's probably the most correct word for this sentence or for these sentences. Actually, Beatles, and it's most common use words near I love in huge corpus and use this knowledge like the prior of our correct answer. So generally, this approach works with the textual aggregation, just like the summarization problem. Then I need to summarize several answers to now one. So probably it may sound like, okay, it sounds like something difficult because I need to use T5, provide new tokenizer, aggregate several answers, choose one, and something like that. But of course, if someone speaks about it, it's probably was written by one persons. So generally, all these algorithms implemented in CrowdKit, like several more, using this library, you may perfectly work with crowd data, calculate the metric, aggregate the data, and do one cool things. And in this case, it's actually just the couple lines of code, because in this, for instance, work code for text aggregation using the T5 model, using the crowd speech. It's a crowdsourced dataset with transcription information in several languages, and aggregate this data, just applying the transformation using the T5, and use this model like the aggregation of several answers. So you may either use this example or try to collect or annotate your own data set using this perfect promo code bug out on Toloka, of course. But generally, the previous method works perfectly from any kind of the data, from crowdsourcing. It's maybe from Toloka, or probably from one crowdsourcing service. I don't know, for example, from Mechanical Turk, from Scale, from Up, and from anything, but probably from your students, and try to use it for your own and aggregate several annotation data, for example, to improve model of transcription or translation or question answering or anything else, to choose most correct answer for your tasks. So it's something like 25 minutes, and I'm going to ask you any question.
Yeah, awesome. Thanks, Valentin. So I see a question from Kaushal. So when you were talking about weighted majority vote, how do you calculate estimated quality?
Oh, so the quality estimation is one of the perfect question rely on this crowdsourcing task, and generally on the whole crowdsourcing tasks, actually, because classically we work in machine learning, like the knowledge that our data sets is totally perfect, correct, and so and central. But then speak about crowdsourcing. Actually, there's no one truth. No, it's actually possible to provide probably the correct answer to our data, but generally, this is a really holistic question: what is the correctness probably on some tasks? But generally, the measure of quality of provided labels may works like the probability of our answers. Probably when they use the majority vote, they may calculate the total possible error on this data. For example, if this speaks about the just classical majority vote approach without weights, they may say that's okay, the possible error rate, just the number of non-common answers. Then this speaks about majority vote approach. They may also use not only the probability of correct answer, but also like the probability of an incorrect answer. So this value may be used like the estimation or the quality on one example, and using the macro aggregation, you may also estimate the quality of the whole data sets.
Kaushal, do you have any follow-up questions?
Hi, Valentin. Thanks for your answer. I was just wondering that does this estimated quality parameter have anything to do with the skill of the performer?
So I understand, if I understand your question correctly, the skill, just like the measure or the probability of this answer, and generally they may use this like the theory to calculate joint probability of these events. Generally, the providing of answer is the event, and the main joint probability of every answer. For example, in this image, like the about the dog and cats, and choose the most possible and use the something like just 1 minus the possible value, obtain the mistake rate, and aggregation or using the mean of these errors, you may calculate the possible errors at this data set generally.
So you're basically calculating their errors of every annotator, and you'll sort of make the aggregated estimator?
They calculate the value of correct answer, and the incorrect answer is just 1 minus this value. So they use these weights like the weights in majority vote, not just the amount of this value, but the weights. So they may choose that's actually there's several answers for dog, and with some weights, and several answers for the cat. So they may calculate the joint probability of this event like the correct, the true value of our variable is the dog. And using this approach, you may also calculate 1 minus the error, like the probability. And yeah, then they speak about estimation or the quality of the whole data sets, not point-wise on some one example. It's possible to use just the mean of this area, just using the mean value. Yeah, sure.
And is there someone who is responsible of making like a quality control of a data set?
Actually, if we speak about crowdsourcing,
yeah, basically how you see the quality of a data set.
Generally, if you speak, for example, in Toloka and crowdsourcing, I think the most correct answer, the person who is responsible for the general quality of data sets is actually the data engineer, the data scientist mostly, because the configuration of the crowdsourcing system is something like configuration of generally like the model training processes. It's simple on the hands, but difficult on the math. It's not true. It's not always difficult on the math, but generally. And in this case, the responsibility of configuration and measuring the quality of obtained data on the data science, actually, as for me, probably in some not crowdsourcing, but managed crowd services, then you provide just the tasks for one manager, the responsibility of the providing correct answer on crowd manager. But generally, it's something like the data scientist too, the person who know how to configure the system.
Okay. I see a question from David. I think you asked this question when you were talking about majority vote on texts. David, you can unmute yourself and ask your question if you want, or I can read your question.
Yeah, I can read it. I can just repeat it. Yeah. So does any of these algorithms take into account the complexity of the samples? So for example, yeah, sorry.
Sorry, from my point, actually, there's no anyone algorithm in this presentation that's taken account the complexity of these some samples. But I may speak about a couple of them. Actually, you may assume the scheme of majority vote algorithms like David Skin's generally that may use also the latent variable like the hardness, like the complexity of every sample. But these schemes actually need real huge amount of data to not overfit on the data. And generally, it's not common use thing because generally, as for me, there's not popular than several tasks in crowd data have real different level of complexity. Probably some of them may be real difficult, and you may calculate something like the consistency of these data sets. For example, the how in terms of majority algorithms, how many people will be agree with the most common value. And in this case, you may calculate the possible agreement of the person or the humans to provide. Does it's really difficult to be with the consistent opinion or not, and use this kind of like the complexity. But generally, in terms of crowdsourcing tasks, there's not real diverse complexity of the task because it's actually in most common case that I know, there's a similar task to now one, and just some of them maybe something like anomaly, and using the anomaly detection on this data, it's most common things that you made to do. But generally, if we're speaking about method to what was used, actually complexity, actually you may imagine this scheme. Then speak about EM algorithm, like the David scheme, like the expectation maximization of like the likelihood. You may also note that actually they may use not EM algorithm, but just something like gradient descent. So then the use of the gradient descent is one cool thing for every task. And in this case, they may use the latent variable, like the ability to provide correct answer. They may use latent variable like the complexity of the tasks. And they may use gradient descent to optimize the whole scheme. And generally it was worked perfectly, and CrowdKit presented method that's names ZBS. Actually, it's something like zero-based skill, like the using the 0-point estimation to know the complexity of every task, the correctness of every performer, and optimize this model using the gradient descent on sliding window. So generally, there's several methods in the whole world known for me that use the complexity of the samples. It's mostly works with categorical information, but it possible may be converted to textual data, but actually I don't know. Honestly, there is no one method what I know on textual information. So
Thank you for the answer, Valentin. I guess it's more like dependent on the task at hand. Right?
yeah, sure.
Yeah.
Mm-hmm. I see question from Mike. Are you not risking pre-trained model overriding annotators and imposing its biases on the labels? Is this not crossing programmatic labeling?
Generally, when we speak about any behavioral transformers, there's actually they may speak about the risks, but I think that, no, it's not for just the thinking. They use the knowledge of this corpus like just the prior of the lexical construction generally, and via speaking about the T5, for example, model. Generally, at VLDB conference to the past year, it was the top one method in the competition of textual aggregation, and T5 method works the better what everyone with a real huge score at the leaderboard. So generally in these tasks, in the known task for me, there's no so overriding, but generally it's possible, but just like the possible of actually everything. But so yes, then let's speak about summarization and T5 and pre-trained model. In this case, it's possible to provide any bias, but this is a real cool computation for every model to knew the whole corpus and knew this corpus without bias. And generally, for example, if it speaks about, I know, models trained on Twitter and models trained on, for example, Reddit, may provide different answers. That's true, because they may see the different lexical construction, generally something like different languages in forum and in Twitter. And in this case, this model may provide different answers. But if they assume that model was trained on huge corpus from the same domain, for example, if you speak about aggregation from question answering on something like Twitter, and they train our model on the Twitter, they may think that's okay, there is no bias here because they train on the same domain too.
Yeah, Mike, do you have a follow-up question?
Yes, I do actually, and I wrote it up. So my issue is that you are ceding the final authority to the model, right? And how about a slightly different scheme? You still use the model to arbitrate the different answers of different annotators, but ultimately you pick the one answer that is semantically closest to the centroid that you calculate of all the answers. So the model still has a say, but the final formulation of the label belongs to a human. Mm-hmm. Hopefully the most deserving human, and who is the most deserving human is up to the model, but it's still a human provided label, not model provided.
Yeah, I'm totally agree, and I may also note the one of the perfect crowdsourcing approach that actually they may use the crowdsourcing just to post verification probably of our answer, and in this case, then they need to use just the answer. Does this answers see like the possible answer for our question? They may speak about this task like the classification and the previous cool and huge scams like the David scheme, like the majority one and several one may works perfectly. And in this case, what it was actually answer from human. Okay, this answer are possible, seems cool and so on. And in this case, they negotiate the risk or the model bias. Yeah.
Thanks.
I'm wondering, like, when you guys work with different languages, are the annotators their native speakers? Or you find like people who are native speaker to like certain language?
Actually, the crowd kit, and in this case, in the question in chat, is the something like language agnostic thing, because okay, it's on Python thing, but generally there are several models like the T5s was presented on huge amount of languages, probably some actually not so common languages not preserved generally, but the models from what we use in CrowdKit, like the standard, just cherry-picked from Hugging Face generally, yeah. And it's possible to explore Hugging Face and pick an one. If we speak about our data set, there's several language on crowd speech. Actually, I remember this is something like English, French, and now one, but actually I don't remember, to be honest. If you speak about the Toloka, like the crowdsourcing platform, there's a 40 language on the platform with annotators, what a native speaker on this language, and really you may pick in one language too, probably, and just check what person know this language, but really it's more than 40 languages on the platform, and more than millions humans annotators on the platform too. Okay, it's something like the promo. So about one question, how about instead of the model generation, pick a random of human provided labels, so the scorer has semantic similarity, the centroid or the of answer. Oh, so Mike, I think I discussed this methods too, because
you already answered that.
Yeah.
So maybe it will be better to give all answer to one tasks to our workers who could choose the best one. Generally, it's possible thing, but generally it's difficult sometimes to describe what's a better answer for what. And in this case, for example, when we speak about the overlapping, yeah, the classical schemas of overlapping using the 3 or sometimes 5 thing, but actually the several research papers show that's actually optimal overlap value is something like 10 or 11, and in this case they're choosing the most correct answer from 10 or 11 classes actually difficult. And if we speak about this task on next step, like the aggregation, there's a really difficult to use the previous categorization model, because this is a different class and there's no one probability model to work with actually not continuous in this case, but it's something like overlap multiplied by the items values of classes. And in this case, no one classical algorithm of categorical data doesn't work well, because it's a brain teaser really for this task. So yeah, but provide possible answer and just picking does it correct or not, the real easy approach. I know in now one really that's based on side-by-side mechanic. Just Valia, who brings in our one term from in our one area. The side-by-side mechanics is an approach that's often used ranking system. Then they need to choose the most relevant item from the couple one. So this approach actually, it's a good teaser, may be used for a wide range of the tasks. Classically, it was used to search relevance approach, to ranking system, because then they may choose the most relevant from the couple one. They may use the several couples of items, several pairs of items, and actually provide the whole list of the preferences using the pairwise compression. So this approach what used to ranking system may also used to candidate generation on text summarization on text generation tasks too, because they may choose better one answer from the both of them. And like the teaser, the method of side-by-side comprehension may be also used in reinforcement learning too, because then we speak about any strategy, for example, of the car on gym data sets, or generally anything of robotics or something like that. It's possibly difficult to describe the reward function. What does the good reward function, for example, for any robotics or something like that? It's a real difficult task to route this reward function. But if we speak about side-by-side compression, they may score to strategy on this moment and choose the most interesting for now one. For example, in terms of robotics, it's a to pose estimate or pose or the robot or something like that, or some agent actually on some area, and choose the most stable from the couple of them. And this approach worked perfectly at good teacher from, and probably now one talk, how to use ranking system to learn reinforcement learning algorithms. So never mind.
Next time.
Yeah.
Cool. Do we have other questions?
Thank you for all your answers. So I was wondering that, let's say I use Toloka for my whatever purposes. Is there a way I can test my interface before actually deploying my whole project on production server?
Actually, there's an environment what names Sandbox Toloka. It may use actually for you. You may launch the project and relog in like the performer and use this interface for you. But you may also, like the requester or the data labeling, use the preview button somewhere on the left corner and try to annotate data on this interface. But I may also know that, Valia, are you here? You may come to community and ask anything about Toloka easily, because in these questions, easy to answer with screenshots actually are not on only, okay, in this button you may pick, or in this one, or just write with websites. So feel free to ask this question. Probably, I know, on my email, go to the, okay, I have a Toloka for capture letter, or, okay. So, or go to community in Slack and feel free to ask anything. We're really happy to help you.
Thank you, because I have a couple questions on that front, so I can probably discuss. You said maybe on the Slack, right?
Yeah, sure.
Okay, all right.
Okay, I don't know, Kaushal, if you are in Bhagout Slack, you can find Valentina there, and she will provide you all links, so how you can reach out to them. I will tag her in my message, so you definitely will find the guys to connect with them and explore further.
All right.
Cool. Awesome. Thanks, Valentin. Thanks everyone for joining this talk and asking your amazing questions. The video recording will be available maybe in a week or so. It just takes some time to do editing and post it.
Don't worry.
But it will be eventually. Don't worry, and I will share on Bhagout community. Okay, cool. Thanks a lot, and have a nice evening, day, wherever you are in the world, and take care. Bye-bye.
Thank you. Bye-bye.